good. So now let's see the second example, which is about the correlation test. So first we have our data file, the height.csv. And in this file, we can see that we have 4 columns. And these are data related to different people. So we have the height of these people, the weight, the shoe size, and the gender. And in this specific example, we are going to check if there is any correlation between the height and the shoe size of these people. So let's go to the RStudio and conduct our tests. So first of all, I will load a library that I will use to generate a specific scatter plot. And then I will also load the data from the height CSV file. And then also I will create variables that contains the values related to the weight, height, and the shoe size. So let me just run this part of the code. And then as you can see, we have these values, and these are related to a data set from 109 people. To have some descriptive statistics, so we can create the box plots related to the shoe size and the height. So let me run this part of the code. So let me go to the first plot. So this is for the shoe size, as you can see here on the x-axis, and then on the y-axis we can see the value of the shoe size. And for the second variable, which is the height, we can see also here on the y-axis the values. So now we have generated also the box plots. We can generate a scatter plot. So this is a scatter plot. I will generate it for you. So the scatter plot actually represents, the 2 variables in relation to each other, and then you can see all the data points here in this rectangle. So on the x-axis you can see the height, and then on the y-axis you can see the shoe size. But then also we have this, as you can see here on line 27, we are having this fitting linear model to this data. So we can see the, let's say, the relationship between these 2 variables. So as we can see from this scatter plot, there is a sort of a tendency of correlation between these 2 variables, because as we can see that the height increases. So as the height increases, also the shoe size increases according to this linear model that we have used to fit this data. Okay, so we have observed that there might be a correlation, as the height increases, the shoe size increases, but we don't have any statistical significance yet. So we need to conduct the statistical test. Before doing that, also I've said that I have loaded a library to generate a scatter plot. This is another way to generate the scatter plots. It might be more beautiful than the previous. As you can see here, we have a different style, and this gray area here represents the confidence interval. So let's go and conduct the check for the assumptions to know which test we can conduct to check for the correlation. So first of all, we check the normal distribution of these data. So we run the Shapiro-Wilk normality test. So by running this, I can see that for the shoe size, we have a p-value which is less than 0.05. This means that the data are not normally distributed. So the assumptions for the shoe size is not satisfied. For the heights, I can see that the p-value is greater than 0.05. So this means that the height, the data here, we have it normally distributed. But as we are comparing 2 samples and one of them is not normally distributed, then the assumption of normal distribution is not anymore satisfied. So let's only just see how we can also run the test for the homogeneity of the variances. Here we run the test, the Fisher's F-test, and the p-value is again less than 0.05. And this means that also the variances are not equal. So we don't also satisfy the second hypothesis about the homogeneity of variances. So as we did not satisfy the assumptions for running the Pearson test, so we will conduct the Spearman correlation test. And since also we have too many data points, we have 109, so we don't need to conduct the Kendall's correlation test. So I will uncomment this part of the code. So here we will conduct the Spearman correlation and calculate the Spearman rho coefficient. So I will run this part of the code, and this is the Spearman correlation. And we can check that the p-value is less than 0.05. So this means that the correlation is statistically significant. So we have observed from the scatter plot that there is a tendency of having correlation, but with this test, with the Spearman correlation test, we have found that there is a significantly statistically significant correlation between the height and the shoe size. And of course also we can check the rho coefficient. Here we have the rho coefficient, and the value is 0.4306612, and this is also a positive number, which means that we have a positive correlation between the two variables. And of course, as I mentioned, the p-value is less than 0.05, then we have to say that this correlation is statistically significant.